Hello students, in this video lecture I will explain chapter 2, rather I will start chapter 2 of your physics, force and pressure, motion. And today I will explain in this video lecture about rest and motion. Now, rest and motion. Imagine a book lying on your study table. You can say that the book is at rest with respect to the surrounding, such as a chair, a table lamp, etc. As the earth is continuously revolving around the sun, anything lying on the surface on the earth is also in motion. Hence, you can say that the book is in motion with respect to the sun. Therefore, rest and motion are not absolute but relative terms. Now, what do you understand by this introduction? See, whatever you will see around you, okay, your chair, your tables, your book, okay, these are all at rest. Yes, these are all at rest. But when you are, imagine that when you are traveling by a train, okay, and the train is in motion, and how will you understand whether the train is in motion or not? You will only understand if you look outside the window. If you look outside the window, you will see that the objects are moving, okay, which means you are changing your position with respect to the time. But if any object does not change its position with respect to time, then we will say that object is at rest. Okay, so for example, we know that earth continuously revolves around the sun. But if you look around yourself, you will not even understand that the earth is moving, right? For example, do you see any change in your neighbors suddenly, or in your nearby suddenly? Are the objects, are the houses, are the roads, they are moving? No. Are they changing their position? No. You will not understand. But if we compare our position with the sun, then we will say that we are in motion. And that is the reason that the sun rise and sunset occurs, right? Because of the motion of the earth, isn't it? So, rest and motion are relative terms, which mean whenever you are describing any object at rest, you have to compare that object with any other object which is at motion. Or whenever you want to say that any object is in motion, then you have to compare that object with some object which is at rest. Otherwise, we will not understand that whether the object is at rest or at motion. Okay. So, rest and motion, they are relative terms. Okay. So, if you want to define rest, then you have to relate it with or compare it with motion. If you want to define motion, then you have to compare it with the rest. Rest and motion are relative. An object may be in motion with respect to another object, but may be stationary. Stationary means which doesn't move with a third object. For example, you are riding in a train and you pass by a person standing along the track. The person standing along the track will see you as being in motion, but the person sitting next to you on the train will be stationary with respect to you. So this is a very nice example, okay, to show that rest and motion, they are relative terms. So when we travel by a train or in a train, okay, if you look to your fellow passenger, you will not understand whether the train is in motion or not. Yes, because they are stationary with respect to you, they are not moving. But if you look out and if you pass by a person, okay, standing along the track, as you can see in the picture, okay, in figure 2.1, that a person is standing beside the track. So the person, when you pass by, then you will see, you can understand that you are in motion. Okay, So dear student, what we understand from this, that rest and motion, they are related to each other. Okay, if you want to describe any object which is in motion, you have to take help, or if you have to compare that object with another object which is not moving, then only you will come to know that the object is moving or not. Yes. Some example illustrating or describing rest and motion. If you look around, you see a number of things. Some of them are moving from one place to another, while others are stationary. That means they are not moving. For example, you see a vehicles moving on the road, aeroplane flying in the sky, children running in the park, and water flowing in the river. These are said to be in motion. You must have seen a chair lying in a room, a car parked in a garage, a clock hanging on a wall, etc. These things do not appear to move and they are said to be stationary or at rest. Okay, so what does this example says? This example says that if you see anything which is moving around, okay, which is changing its position with time, okay, then you should immediately understand that object is in motion. But if you see that object in that place only, it is not changing its position with time, then you should know that object is in rest. Newton laws of motion. Now Newton, the famous scientist, okay, he has made three laws, okay. These are also known as laws of motion. So according to the first law of motion, an object at rest remain at rest, and when in motion remain in motion, unless acted upon by an unbalanced force. So what does it mean? It means that if any object is at rest, it will be in rest only until you apply some force. If any object is in motion, it will be continuously in motion only until some force is applied. For example, until and unless you kick the ball, it will not move. Yes, and in order to stop a moving ball also, force is required. Second law, acceleration is directly proportional to the force acting on an object and inversely proportional to its mass. Okay, now for example, when you accelerate your cycle, then you have to apply more force. Yes, but imagine that with the same force, can you accelerate a car? Yes, maybe no, because the mass is more, right? So which means if mass is more, then more amount of force is required to accelerate. If mass is less, then less amount of force is required to accelerate. Okay. Law number 3 or third law, for every action there is an equal and opposite reaction, right? So according to Newton, he states that in nature there are pair of force. One is known as action force, another known as reaction force. Action and reaction force always exist together but in different object. For example, here you can see if you blow a balloon and just leave it, okay, without tying its mouth, then what will happen? You will see that the balloon is moving forward, okay, but the air is moving backward. So this is an action and reaction force. So what is the action? Action is the balloon is moving forward, and the reaction is that air is moving backward. Okay, so both are acting in the opposite direction. So today I will explain till here, right? So watch this video nicely. In the next video I will explain the types of motion. Okay, thank you.